In this video, we're going to finish off titrations by taking a look at one more concept that's actually really neat and gives you a great deal of information about the titration that occurred. So once again, we can see a titration happening here, and we can see that we have a pH that's above 7 for this titration. Here's the pH is equal to 7 line. The pH at equivalence point is above 7. And so what that means is that we have a strong base, weak acid titration. And in our flask, we're starting off with the weak acid because our pH is less than 7. And essentially, we start to add the base. There's a sharp increase, but then it slows down because we're in our buffer region, which is where a buffer sets up between the weak acid and its conjugate base to resist pH change. But eventually, you break past that limit, and you have that sharp increase that starts to happen, and you want to aim for that middle portion here to get to your equivalence point. But if you continue to add more strong base, now you've overshot, and your pH is determined by the strong base because you've already neutralized or reacted with all the weak acid that was there. And that's what the equivalence point is. The equivalence point is where your strong base has completely reacted with your with all the weak acid that was there. So a really cool point, though, that you can take a look at is something called the halfway point to equivalence. So let's say this was, and this shouldn't say endpoint here. This should say equivalence point because we're assuming that we know the exact equivalence point in this titration curve. Remember, the endpoint is the color change. So here we have our equivalence point. And let's say that our equivalence point happened at about 50 mils of our base being added. Well, you can go halfway to that. You can find the point where you're about halfway to 50 mils. So that's 25 mils. And at that point there, you can go find your pH at that point. And the cool thing about that is that your pH at that point is going to be equal to your pKa. And what does that mean? It's kind of weird, but we didn't really learn about pKa in a lot of detail. pKa is essentially the negative log of your Ka. So if you know the Ka, or the pKa, is equal to the pH here, you can find your pKa. And then once you have your pKa, you could find your Ka, because technically, if you want to find Ka, you would just do 10 to the negative pKa. So that allows you to figure out your acid dissociation constant if you know where the halfway point is. And why is it that the pH is equal to pKa? There's another equation involved there, and what's special about this region involves that equation. The main part that's special about this point, though, is that at this point, halfway through equivalence, you actually have equal amounts of your weak acid and your conjugate base, or equal concentrations of your weak acid and your conjugate base, because at this point you've used up half of your weak acid. So half of your weak acid has been converted into its conjugate base. And so that's why the concentrations are equal for those substances within that buffer region there, equal concentrations. And again, it's just another important point that you'll see in more detail later on. But it's the idea that if you know where the equivalence point is, you find that volume, you can find half the volume, find the pH there. It's going to be equal to the pKa. And if you know your pKa, you can find your Ka by doing 10 to the negative pKa. So quite a neat approach. Also, another way you can look at this as well is, let's say you're doing a titration and you know the Ka of your weak acid. If you know the Ka of your weak acid, you could find the pKa. And once you've essentially reached the pH that's equal to that pKa, you can already know where your equivalence point is going to be. So if I say, well, I know that my pKa is X, therefore my pH must be X. Well, oh look, I've reached X over here at 25 mils. I know that times 2, so I'm halfway to the equivalence point, is going to be 50 mils, and that's where my equivalence point will be. So that's another way you can rapidly find where your equivalence point would be using knowledge of this interesting relationship that exists here. So this was, again, another little summary of titration curves, but with the additional concept of pKa in there thrown in with halfway to equivalence. And there's another video that you'll see in your learning goals, in your documents, that goes over this pKa concept in a bit more detail, just in case you want some more enrichment on the topic.